This week on Waterways. Global climate change and rising sea levels in South Florida. Florida's coastline beckons people from all over the country and the world. A beachfront home in Florida, a vacation spot on a Key West canal, a Miami waterfront condominium. Being close to the water is very desirable for many people. The closer to the water, the more valuable the property. But Florida is disappearing. Sea level rise is submerging the coastal communities of Florida and jeopardizing investments and the state economy. Along with personal and financial loss of property comes a loss of habitat and wildlife. Climate change is real and is impacting the people and the landscape of South Florida.
In the past, there were some fairly dramatic periods of sea level rise that caused the Native Americans and other indigenous people around the world to rapidly and dramatically change where they lived and move inland and upslope. But again, for the last 3,000 years or so, the sea level has been quite stable, and we have moved into the shore and invested and built our homes and started our businesses and built all this infrastructure, everything from roads to bridges and power lines and everything else, which makes our modern society possible. But relatively recently, the trend in sea level rise has been a rapid acceleration.
Between 1000 BC and the year 1900, sea level rose about 1.5 inches every 100 years. In Florida, in the past 100 years alone, sea level has risen more than 8 inches. The National Oceanic and Atmospheric Administration, or NOAA, the leading U.S. agency studying climate change and sea level rise, estimates global sea level will rise between 8 to 80 inches by 2100. The exact amount will be determined by the amount of ice sheet losses and increases in ocean warming. Under the worst-case scenario, by the year 2100, 56% of developed area in South Florida could be underwater at high tide. Early in the morning of Monday, October 24th, 2005, the people of South Florida huddled inside homes and hurricane shelters, bracing themselves for the 13th hurricane in a record-breaking storm season. Hurricane Wilma had reached Category 5 strength winds. But by the time it passed the Florida Keys, the storm was downgraded to a Category 3. Wind gusts up to 120 miles per hour wreaked havoc in the Keys. But it was the flooding after the storm that caused the most damage. Not since Hurricane Betsy in 1965 had the Keys faced such drastic flooding.
We got interested in sea level rise when Hurricane Wilma in 2005 flooded almost the entire Florida Keys with seawater. And Big Pine Key, where we're now sitting, was no exception. In fact, my yard was underwater by about 2 feet. And we were able to see and visualize what sea level rise would look like for the first time.
Though the eye of Hurricane Wilma passed just north of the Keys, sparing the island chain from the highest winds and heaviest rains, the ocean surrounding the islands rose quickly, inundating many island communities in 2 to 3 feet of water in less than 15 minutes. Coastal flooding in Key West typically occurs when water levels reach 3 feet above mean sea level. When storm tides for Wilma reached up to 6.5 feet above sea level, almost the entire eastern half of Key West was underwater. In 2007, Chris Berg of the Nature Conservancy initiated a research project to identify impacts of sea level rise in the Florida Keys. They created digital models illustrating sea level rise scenarios from 7 inches to 4.6 feet to reflect the best available range of sea level rise for the year 2100.
We got very concerned about it, and we decided we should take a look at the elevation of the islands of the Florida Keys, and then use what's called bathtub modeling to digitally, using computer simulations, artificially raise the elevation of the ocean by different increments.
Since more than 90% of the Keys land area is less than 5 feet above sea level, scenario mapping tools help illustrate the potential dangers facing our communities from rising sea levels. The Nature Conservancy's online mapping tool, available at coastalresilience.org, enables web users to simulate what Big Pine Key in the Middle Florida Keys would look like with a sea level rise of 1 to 4 feet, or simulate a storm surge such as the one from Hurricane Wilma, or a combination of both rise and surge. The mapping tool uses real-world elevation data along with infrastructure locations, facilities like hospitals, and the habitat ranges of protected species.
You look at South Florida or anywhere else, you say, oh, well, we'll move inland. Well, maybe some places you can move inland. South Florida, we have the Everglades. The farther inland we get, the lower it gets. So we're going to lose it all this century.
Sea level is rising because the atmosphere and the ocean are warming. The Earth is warming because of greenhouse gases. In 1824, French mathematician and physicist Joseph Fourier theorized that some gases trap heat within the Earth's atmosphere. These gases, like methane and carbon dioxide, are called greenhouse gases. Without greenhouse gases, life on Earth would be far too cold. Greenhouse gases keep the sun's heat from bouncing back into space. But through human activity, the amount of greenhouse gases in our atmosphere has soared. Through the burning of fossil fuels, such as coal, oil, and natural gas, approximately 10 billion tons of carbon dioxide, also known as CO2, are added to the atmosphere every year. However, only 6 to 7 billion tons of CO2 are removed from the atmosphere by plants and oceans. More CO2 is entering the atmosphere than is being removed. This imbalance is the fundamental cause of our accelerated climate change. For more than 100 years, NOAA has been monitoring rising sea levels with tidal gauges that pepper America's coastline. NOAA also operates environmental satellites that perpetually monitor the planet. Data from these satellites is used to measure numerous environmental factors, including the surface temperature of the ocean, an indicator of climate change. According to NOAA data, 2012 was the warmest year ever recorded in the U.S. since record-keeping began in 1895. The latest climate projections call for the globe to warm between 3.2 degrees Fahrenheit and 7.2 degrees Fahrenheit by 2100, depending on the amount of future greenhouse gas emissions. As the atmosphere gets hotter, ocean temperatures also increase, and warmer water has a greater volume than cooler water. So as the ocean heats up, it gets larger, and sea level rises.
The warming of the ocean will maybe add nearly another foot this century. The the melting of the alpine glaciers, which is dramatic, that may add another 8 or 9 inches this century. But the huge potential for sea level rise is the melting of the ice sheet. Greenland has enough ice that if it all melted, it could raise sea level by 23, 24 feet. The West Antarctic ice sheet alone has enough ice to raise sea level by 25 feet.
While the world's ice sheets won't totally disappear by the end of the century, they are melting at an alarming pace. Single weather events can't be directly linked to climate change. A study published by the Proceedings of the National Academy of Sciences estimates that for every 1.8 degrees Fahrenheit increase in global temperatures, there could be up to a 7-fold increase in the risk of extreme storm surge events.
Yeah, there's a common misperception about the differences between climate and weather. So weather is what's happening now. Right now it's a little bit windy and it's a little bit cool and not a cloud in the sky. That's the conditions at the moment. And climate is the trend over decades or centuries. So in order for me to say that the climate has changed here, I would have to have these relatively windy, relatively cool, relatively dry conditions for many, many, many days, weeks, months, and years on end before I could say that the climate is trending towards cool and dry and windy. You know, one snowstorm or one hurricane or one windy day does not make climate change. But when those things multiply themselves and the trends change, that's climate.
The crisis we faced was once called global warming. And while the atmosphere and oceans are warming, it's more accurate to call the phenomenon global climate change. Some places may get more rain and floods, while other places may see more heat waves and droughts. But everywhere, the waters will be rising. Cape Sable is the southernmost point in the United States mainland and covers the western portion of Everglades National Park. Scientists have been studying Cape Sable for years and tracking the changes caused by climate change.
Since the 1930s, we have been measuring and studying what's happening at Cape Sable, and it is a really awesome place, not only for science, but to visit. The scientists love Cape Sable because it is an undeveloped part of Florida, which you can compare directly to developed parts of Miami. What we are seeing happening at Cape Sable since the 1930s is sea level is rising, and up to 80 times a year now. High tides are pushing over the Marl ridgeline, and salt water is now pushing into what used to be a freshwater lagoon.
"50 to 60% of land-based Everglades National Park is below 3 feet in elevation. This wild place, where plants and animals rely on healthy freshwater flow for survival, is facing an inundation of salt water."
When we think about the animals and the plants that will be affected by the sea level rise along Cape Sable, you're going to be thinking a lot about some of the plants that are unable to migrate or move. Birds perhaps can move somewhere else as long as they can still find habitat and food, and perhaps that's the saving grace for the endangered Cape Sable seaside sparrow. But there are going to be plants that are unable to migrate quicker than the sea level is rising. We already see the mangroves are marching inland, and that's because the sea level is rising. The salt water is overtopping some of the natural barriers. The mangroves are moving inland as the sea level rises. If mangroves are moving in,